Engineering education with a TIMS in the AI era. Whilst technology changes, fundamental principles remain the same. In the lab is where engineers first develop their skills by putting the theory into practice, making the math come alive during experimentation and consolidate their understanding of the theory. The versatile TIMS unit enables professors to choose which topics they need students to develop proficiency in based on their required lab program. The unique TIMS methodology is where math is represented by the block diagram, and each block is implemented as a separate real electrical circuit module, patched together to build complete systems for the student to study. Let's hear from Tim Hooper himself about this methodology.
What do you mean by modelling, and how is modelling relevant to TIMS?
It is a modelling system and it makes models of block diagrams. That's how I look at it. And every communications textbook is full of block diagrams.
Okay.
And each one of those blocks is usually a simple element. That's what these modules are, simple elements of communication systems.
Choosing from a selection of these elements enables the building of introductory through to advanced analog and digital schemes, which are fully documented in the included lab manuals. From AM and FM, sampling, to OFDM, spread spectrum. Bit error rates, signals and systems, equalization, radar, and much more. Let us quickly browse through an example experiment on equalization. Some theory is provided as well as steps, patching diagrams and tasks throughout the experiment that the student will build. Various modules as needed are inserted and patched together systematically to encourage discipline and procedure, especially in complex setups. Control knobs are not marked, so students must take measurements throughout using oscilloscopes. External scopes as well as the built-in digital scope provided can be used. The frequency spectrum function is used extensively. At the engineering level, students are expected to fully understand what they are seeing and why. Professors can edit the experiments to suit their curriculum outcomes. Institutions in over 50 countries use TIMS, and feedback is that students love using the equipment and find the labs to be most engaging. TIMS stays up to date. A new software-defined radio modules integrates seamlessly into the TIMS architecture. The open architecture of TIMS enables capstone projects and custom design modules to be incorporated by users into their experiments. The TIMS lab methodology is available in the open-ended flagship, TIMS 300 series, the compact ETT unit, and in cloud simulator tutor TIMS, with no programming involved and as remote access hardware by subscription. Something to meet all curriculum and price points. Find out how TIMS can fit into your lab program from your local distributor or contact us directly.